All right, today we're going to talk about the unit circle and how to fill it out. And in class tomorrow, we'll talk about what it all means. I might be able to give you a little preview during these notes. But yeah, the unit circle, in my mind, everything in trig revolves around the unit circle. It is crazy important. Now, budget your space because we're going to have 4 layers of information around the circle. And every axis and every dot here is going to have 4 things attached to it. First thing we're going to talk about is degrees. Now, the degrees, just like when we plot graphs, start in standard position, and all the way around the circle is 360 degrees. So that means that halfway is 180. So halfway to halfway up here would be 90 degrees. And then what we could do actually is count it off. 0, 90, plus 90 is 180, plus 90 is 270, plus 90 is 360. All right, so this part right here, this is actually a 45-degree angle right here. You don't got to draw this line. Sorry, don't draw that. But that's 5 degrees, which means that this is 45 here. So then count off the middle dots. 45 plus 45 is 90, plus 45 is 135, 180, 225, 225 plus 45 is 270, 315, and then plus 45 is 360. Now this next one here is 30 degrees, right? So that means this is 30. So skip the middle dots, but we're going to count it off again by 30s. So 30, this is 60, 90, 120, 150, 180, 210, 240, 270, 300, and 315. Now, the pattern that we just did there, I started off with the axes, then I went to the 45 dots, or the middle dots, then I went to the outside dots. This is what the pattern that I'm gonna use to fill out this entire unit circle. All right, the next thing we're gonna talk about is radians. Now, radians we're a little bit familiar with now. Starts at 0, all the way around is 2 pi, which means that halfway would be pi, which means that 90 degrees is the same thing as pi halves. Right? Now, count it off. 0, 1 pi half, 2 pi halves. What's 2 halves? 2 halves is 1. This is 3 pi halves. 4 pi halves is 4 halves is 2. Right? So now, 0 to pi halves. We're going on to the middle now. What's halfway to half? A quarter or a fourth. So this is pi fourths. Then count it off by the middles and axes. 1 pi fourth, 2 pi fourths. 2 fourths is a half. This is 3 pi fourths, 4 pi fourths. The axes act as a benchmark or a checkpoint. 4 fourths. This is 5 pi fourths. 6 fourths reduces to 3 halves. 7 pi fourths. 8 pi fourths. All right. Now, this is one you might have to memorize. Check this out. 30, 60, 90. It's divided into thirds. Right? So what is 1/2 divided by 3? It's pi sixths. All right, so now the 30s and the axes are going to be pi sixths. So count it off. 1 pi sixth, 2 pi sixths. 2 sixths reduces to 1/3. 3 sixths. 4 pi sixths reduces to 2 pi thirds. 5 pi sixths. 6 pi sixths. All right, then keep going. 6 pi sixths. 7 pi sixths. 8 pi 6 reduces to 4 pi thirds. 9 pi 6 reduces. 10 pi sixths is 5 pi thirds. 11 pi sixths, 12 pi sixths. 12 sixths is 2. So there's our radians. Now what's nice about the unit circle is, remember how we used to have to convert by using the formula? Now if I ask you what is the radian equivalent of 240 degrees, 240 degrees is 4 pi thirds. Or if I ask you what is the degrees equivalent of 315 degrees, or excuse me, 11 pi sixths, it's 315. Okay, so the next thing we're going to talk about are the coordinates of all of these points. Now, again, we're going to start with the axes. What are the coordinates of this point right here? Now, this is the unit circle, and if you recall, the unit circle has a radius of 1. So that means it goes 1 this way, 0 up or down, so this is the point 1, 0. So what's up here? I'm going to have to reduce this, I think. This is 0, 1. This is, oops, negative 1, 0. And this guy here is 0, negative 1. Okay, now let's talk about 45s. Remember, we're done with the axes. Let's go to the middle. And if you recall, this is 45. Let's go to one of them circles I gave you on the back. And we're talking about this 45 degrees here. And if I draw this altitude, or if I draw this angle and drop an altitude, this is right, this is 45 degrees. Now, what else do we know about this? We know that the radius is 1. This is 1. So this is a 45, 45, 90 triangle where the radius is 1. Now, you might recall that in a 45, 45, 90 triangle, this is A root 2. So that means here that A root 2 is the equivalent of 1. Which means you got to divide by root 2. This is 1 divided by root 2 is A. Rationalize the denominator, you get root 2 divided by 2. So that means that each side here is root 2 divided by 2. Root 2 divided by 2 is each one of the legs of this triangle. Which means that the coordinate of this goes root 2 over 2 right, and it goes up root 2 over 2. So that means that the coordinate back here of 45 degrees, like we said, root 2 over 2 this way, root 2 over 2 up, this is root 2 over 2, root 2 divided by 2. That is the coordinate of this triangle, of that point, rather. Now, this point is very similar to this point right here, right? It's the same height. The only thing is, and it went the same amount this way. So the coordinates here are negative root 2 divided by 2, root 2 divided by 2. All right, now again, this first point here is very similar to this point right here. Except now this is still positive root 2 divided by 2. But now the y coordinate is negative root 2 divided by 2. And then this one, very similar. Oops. My bad. Or it's even similar to this one, and this one is quadrant 3, negative root 2 divided by 2, negative root 2 divided by 2. So there are our coordinates so far of the 45s, the middles. All right, which brings us to the 30s. All right, if I was to draw this guy, this is 30. Let's go back to one of our teeny tiny triangles. If I'm talking about a 30 degree drop in altitude, if you recall from a 30, 60, 90, 30, 60, 90, this is A root 3, and the hypotenuse is 2A. Now again, the radius here is 1, which means the hypotenuse to A is 1, which means that A is 1/2. Now if A is 1/2, that means that this side is 1/2, opposite to 30 is A, and opposite to 60 is whatever A is times √3, or another way to say that is √3 divided by 2, half of √3. So the coordinates of this point are √3/2 this way and 1/2 up. All right, so let's come back here. The coordinates of this point here are √3/2 over and 1/2 up. All right, now 60. This 60 degrees, if I did this, this is 60, this is 30, this is still 1. Which means now that this is 1/2, this is √3 divided by 2, so the coordinates of this point are the reverse, 1/2, comma, √3 divided by 2. All right, once you've got that, then it's easy. Come straight across. Come straight across here. This is the same height as this one, right? So this point is the same as this point, but with quadrant 2 signs. So this is negative 1/2, comma, positive √3 divided by 2. This one's the same height as our 30 degrees, right? So it's the same point as this one, except with quadrant 2 sensibilities. So this is negative √3 divided by 2, 1/2. All right, and then try and come up with those other ones yourselves. All right, check your answers with mine. Now, here's what's up. Let's go back and let's draw one of these triangles again. Let's draw out the 30 degree one. Here's 30 degrees. Now, if you recall, this is 1. This traveled √3 divided by 2 this way, and it went 1/2 the way up. If you recall, what is the sine of 30? Well, sine is opposite divided by the hypotenuse, right? So sine is opposite 1/2 divided by 1, right? Which is the y-coordinate. Look at that. Cosine. Cosine is the x-coordinate, or the adjacent rather, divided by the hypotenuse. Adjacent divided by the hypotenuse, which is the x-coordinate. So here's what's up. The coordinates x, y are the equivalent of saying cosine of theta, comma, sine of theta. All right, x, y is alphabetical, so is cosine and sine. So here's what's up, y'all. If I asked you, what is the cosine of 240 degrees? You could go and pull out your calculator and put in the cosine of 240 degrees, and you'll get negative 0.5. Or, what you could do is go to your unit circle, find 240 degrees. Here it is right here. What is the cosine? The cosine is the x-coordinate, and look at that, it's negative 1/2, just like we saw with our calculator. All right, we'll do more of that later tomorrow, but for right now, I want to do more. The last thing are the tangents. Now, if you recall, tangent is opposite divided by the adjacent. So in this case, opposite is 1/2 divided by the adjacent is √3 divided by 2. All right? So 1/2 divided by √3 divided by 2 is 1/2 times the reciprocal, 2 divided by √3, The 2's cancel. You're left with 1 over root 3, which is root 3 divided by 3. So the tangent, this was the tangent of theta, was 1/2 divided by root 3. So this is root 3 divided by 3. Now what we did there was opposite divided by the adjacent, or we did the y-coordinate divided by the x-coordinate. So here's what's up, y'all. Tangent of theta is the same thing as the y-coordinate divided by the x-coordinate. Or in other words, sine divided by the cosine of theta. So y divided by x. What is 0 divided by 1? 0 divided by 1 is 0. Right? This one is easy. Root 2 divided by 2 divided by root 2, root 2 divided by 2 divided by root 2 divided by 2 is 1. This one, when you flip this one, long story short, this is root 3. But this one, when you have 1 divided by 0, divide by 0, you get undefined. All right, now, once you've got these, just file it out here. So, this 0 divided by -1 is still 0. Let's come to this one. This point is the same as this one, but with negative, so negative root 3. This one is -1, negative root 3 divided by 3. It's the same as this one here, right? Only with negatives. Now here, what's negative root 2 divided by 2 by negative root 2 divided by 2? Negative divided by negative is positive. Now, quadrant 3 is all positive. This one is positive root 3 over 3. This one is positive root 3. And then this one. This one is negative root 3 divided by 3, -1, and negative root 3. So that's a little bit about the unit circle. Tomorrow in class, we'll talk about how to use this more. Smith out.